Hello everyone, welcome to GeeklyEDU Math. My name is Guilherme and today we're going to talk about the hyperbolic functions. You've probably heard about them and some of you may have used them once in your life, but do you know exactly what do they mean and where do they come from? Well, let's discover it right now. So, you've probably heard about the hyperbolic functions, but what they really are, right? Well, let's go back and talk about the cosine and sine. We always associate the sine of an angle and the cosine of an angle with the unit circle, right? So we can think about the sine and the cosine as the coordinates for a certain point in the unit circle. Okay, so we have an angle here that reaches this point in the unit circle, and this can be represented as the cosine and the sine of an angle. Okay, now for the hyperbolic functions is the same idea. Okay, for the hyperbolic cosine and the hyperbolic sine it's exactly the same idea, but the difference is we're not associating these functions with the unit circle but with the hyperbola. Okay, that is this weird thing over here. Now, again, for the hyperbola, we have a coordinate for a certain angle that you can represent by the hyperbolic cosine and the hyperbolic sine. Good, but how do we calculate the hyperbolic sine and cosine functions? Well, the hyperbolic sine is defined as e to the x minus e to the negative x over 2. If we plot this graph here for this function, we have this blue line over here, okay? Compared to the sine of x, which is this wave, is pretty different, right? The hyperbolic sine of x actually looks like the tangent of x. They look like, okay, they're pretty similar, but they're not the same, okay? They have different values. If you calculate this hyperbolic sine of x and the tangent of x, you will get different results, right? Now, the hyperbolic cosine is pretty similar also, but instead of a negative sign, we have a positive sign over here. So it's e to the x plus e to the negative x over 2. And if we plot this graph here, we have this blue line over here. Comparing to the cosine, that's also a wave, right? We'll get this blue line and say, well, that's a parabola, right? Not quite, okay? They're pretty similar, but the values, if you calculate the parabola or the hyperbolic cosine of x, you will again get different results. And while we're talking about sines, cosines, we're missing the tangent, all right? The hyperbolic tangent. So tangent is the sine over the cosine, and for the hyperbolic function we have the same thing, okay? For the hyperbolic tangent, we have that this is equals the hyperbolic sine over the hyperbolic cosine. We have the definitions for the sine and the cosine, the hyperbolic sine and the hyperbolic cosine. Let's simplify this 2 over here, right? And we have that the hyperbolic tangent of x is e to the x minus e to the negative x over the e to the x plus e to the negative x, okay? If we plot this graph here, we have the blue line, the hyperbolic tangent of x. And if you compare to the tangent of x, okay, that's the green line here, see that the graph is kind of flipped, right? But we have different values, okay? Totally different. So let's practice a little bit with the hyperbolic functions, okay? We want to demonstrate this identity here, the hyperbolic cosine plus the hyperbolic sine equals e to the x. And also simplify this one, the hyperbolic cosine of x minus the hyperbolic sine of x. So for the first one, we can simply use the definitions for the hyperbolic sine and cosine. okay, and add them up. If you add them up, you see that we have a positive e to the negative x here and a negative e to the negative x over here that we can cancel out and add these two e over x, t to e to the x. And we have that the hyperbolic cosine of x plus the hyperbolic sine of x is 2e to the x over 2. Of course, we simplify, we cancel out this 2, and we have that the hyperbolic cosine of x plus the hyperbolic sine of x equals e to the x. Okay, now the other expression, you notice that's the opposite, right? Instead of a positive sign, we have a negative sign over here. And when we do the calculations again, now we have e to the x minus e to the x. So we cancel out this 2, e to the x, and we add the e to the x to the negative x, okay, with this other e to the negative x over here. Have minus and minus sign over here. If we add them up, and of course simplify the number 2, we have that the hyperbolic cosine of x minus the hyperbolic sine of x equals e to the negative x. Okay? So that's it, guys. Hope you enjoyed and see you next time.
Want to learn more? Check out our other math videos and subscribe for new ones.